Aloha and welcome, citizens of RoboNation, to the biggest and most spectacular of our autonomous vehicle competitions, the second biennial Maritime RobotX Challenge.
In 2016, the competition has moved from Singapore to the fabulous Hawaii, on the beautiful island of Oahu.
The first RobotX was an invitation-only competition, but this year the field was open to any university across the globe that wanted to step up to the challenge and field the required WAM-V boat.
So we're delighted to have 13 teams here from Japan, Australia, South Korea, Singapore, and the US, including a home team from right here in Hawaii.
I think it's really great that we're hosting this competition in Hawaii. It's been really awesome being able to see all of these different teams here from all over the world, and I'm so proud to have them here at home in Hawaii and be able to share all we have to offer here.
We're really excited to be here in Hawaii. What's not to love? You can surf, you can ski, you can go skydiving, you can go ride in a helicopter as I did yesterday to see our huge, beautiful course out here.
It's also the first time in the history of RoboNation that robots will be competing in a true open ocean environment, and we know that nature can make seafaring a difficult and dangerous job.
Singapore was a freshwater environment, it was a confined area, it was a reservoir. Here we're essentially in open water, it's salt water, so we're subject to tidal currents, we're subject to wind, we're subject to different sun conditions that affect that in different ways.
So the real technical challenge here is having multiple issues happening at once and not knowing what those issues are going to be. The environmental sea state can really affect your field of view that you were planning on having. So a lot of these little things can add up to a really technical challenge.
Every team starts with the exact same base platform, the WAM-V, which stands for Wave Adaptive Modular Vessel, a cutting-edge surface vehicle specifically designed to keep its payload steady while traversing rough ocean waters.
The boats themselves are eco-friendly in the sense that there's no fluids on board, nothing to spill. They're all electric powered with closed systems. They're lightweight, easy to assemble, easy to ship. Really an effective vessel for ocean research, reef research, that type of thing.
One of the best things about the WAM-V is its robustness. At first glance, you see the two inflatable hulls and you think, wow, this thing really can't do anything too crazy, but we've had zero stability issues. It has stood up to the task.
Teams must then design hardware and software that can direct the robot through the varied challenge course, with tasks including obstacle avoidance and search and recognition both above and below the water.
In this competition, one of the courses will be to avoid the obstacles in the sea. So basically on our boat, we integrate our laser scanner, cameras, and some other devices to sense the environment. Then we have our onboard computer to perform the algorithm to avoid obstacles in the sea.
We built some hardware specifically for this competition. We've got a underwater vehicle which attaches to the lower deck of our boat and lowers down under the water, has the ability to propel down to the sea floor. It has some sensors so it can tell how far off the sea floor it is. It stays generally below the boat, but it has the ability also to venture out.
The teams have worked incredibly hard and put their best efforts into tackling the difficult ocean course.
So check out robotx.org to see which team takes home the title of Ultimate Robot Boat.